Okay, so we're going to have a look at an example question out of separate chemistry C17. If you're doing combined science, then it is C13, which is groups of the periodic table. This question looks specifically at group 7. Okay, and what we're going to do, we're going to have a look at the question, the mark scheme, and then the examiner's report for each of the parts of it. So the question starts off by talking about fluorine, chlorine, bromine, and iodine, and astatine being parts of group 7, and asks us a simple recall question. Describe the test to show that a gas is chlorine. Okay, so let's look at the mark scheme for this and what we're actually looking for here. Okay, so we're looking for using damp litmus or indicator paper, or just indicator paper. Okay, and what will happen is it bleaches it. It goes white. Okay, so we've got to be careful with this, not to confuse this with some of the other tests like lime water for carbon dioxide, or the squeaky pop hydrogen test using a lit splint. Okay, so in terms of the examiner's report, okay, we've got a comment here saying a good proportion of candidates were able to correctly describe the test for chlorine gas. Of those that knew that litmus paper was used, a large proportion knew the correct result of the test, okay, with some people only scoring 1 mark. So a good example answer here, add damp litmus paper to a test tube of chlorine gas. In the presence of chlorine, the damp litmus paper will be bleached. So an example which isn't so good, okay, we've got add nitric acid to the solution, then add in silver nitrate solution. If chlorine is present, the solution will turn white. All right, so it says some candidates tried to describe the test for chloride ions or carbon dioxide gas rather than chlorine gas, so they gain no credit. So it's important that we know the difference between chloride, which is the negative ion. If we add silver nitrate to that, it does go cloudy. It does give a white precipitate. Chlorine, which is the gas, the test for that is the litmus paper test, with damp litmus paper being bleached. Part B, bromine reacts with hydrogen to form hydrogen bromide. Hydrogen bromide dissolves in water to form a solution. State the name of the solution formed. Okay, so this one, hydrogen bromide is going to dissolve in water to form hydrobromic acid. Okay, and the link there really is if it was hydrogen chloride, HCl, that would form hydrochloric acid. Then C says there's a trend in the colour and state of the halogens at room temperature, the halogens being the group 7 elements. Predict the colour and state of astatine at room temperature. Okay, so for this one, we need to think about the trend going down the group. So we start at the top of the group with fluorines, a very, very pale yellow gas. Chlorine is a slightly darker colour. It's a green, pale green gas. Then to bromine is a brown liquid. Iodine is then a grey solid. Now, astatine is below iodine in the group, so we need to be saying that it is a grey or a black for 1 mark, solid for the 2nd mark. Okay, we've got some examples of answers to part B here. So hydrobromic acid is right. Okay, bromine hydroxide is the sort of incorrect answer that was being given, so we need to be careful not to do that. Part D, we've got bromine, chlorine, and iodine dissolved in water to make aqueous solutions. Potassium iodide solutions added to each of these solutions. Okay, so we've got the observations there, so we're adding potassium iodide. So this is looking at the displacement reactions of the halogens. So we've got the halogen bromine. It's orange to begin with, and it turns brown. We've got chlorine, which is pale green to begin with, and it turns brown. And iodine, which is brown to begin with, and it remains brown. So on adding potassium iodide, we're looking really here at the fact that bromine and chlorine have changed colour, whereas iodine has stayed the same. Now, the question says, explain the observation shown in the table. Whenever we see that word explain, we need to be given a reason for what we're saying. We've got to actually explain why we see those things. So let's have a look at the mark scheme. Okay, so any of these things, okay, there's 4 marks available, and there are 5 points that you could get these marks from. Okay, so something along the lines that chlorine or bromine are more reactive than iodine, or iodine is the least reactive of the halogens. A note here of the halogens listed, a note here, not iodide, it must be iodine. We can say chlorine displaces iodine, or iodine is formed. That gives us the brown colour. With bromine and potassium iodide, bromine displaces iodine, or iodine is formed, or the iodide ions are oxidized. The brown colour of the final mixture is due to the presence of iodine. Okay, and if we add iodine to potassium iodide, there's no change because iodine cannot displace iodine from its compound. In this question, it says those candidates that had some experience of carrying out the reactions were able to answer in a better way than those that were not. Okay, so when we're doing experiments in school, pay attention to them. Okay, they can help you with the answers in the exam. Common error was seen was that potassium was displacing the halogen from the solution rather than a more reactive halogen displacing a less reactive one. And others thought that iodine was the most reactive. Okay, so it's not. It's the least reactive and it's the most easily displaced. So here's an example of a good answer. Bromine displaces iodide from the solution because bromine is more reactive. Chlorine displaces the iodide from solution because chlorine is more reactive, so it turns brown because iodide, or iodine, should have said, is brown. Iodine does not displace itself, so the solution remains brown. So 4 points on that one. And then finally, part E, we've got fluorine reacts vigorously with iron to produce iron 3 fluoride. We've got to write a balanced equation for this. So when we're writing this balanced equation, one thing that we need to remember is fluorine is not just F, it's going to be F2. So we're going to have F2 as a gas plus iron, which is Fe, forming iron 3 fluoride. They've given us this in the question. It's FeF3. So our equation, we need to write down Fe plus F2 gives FeF3, and then we've got to balance it. There are 3 fluorines there and 2 here. So the only way we can do this is to put 3 fluorines on this side. So that gives us a total of 6 atoms, and then double this side to get 6. And when we do that, that doubles the iron, which means we need to double the iron on this side. Okay, so that's just a quick look at that. Here's some examples. Okay, this one, like I mentioned, most common incorrect answer is not to put the 2, okay, after the fluorine symbol. Fluorine is a gas. It does exist as fluorine molecules. Okay, and then this one here is an example of a well-answered question. Okay, so have another look through that. Okay, if there's anything you're not sure about, and just have a look in particular at the comments on the examiner's report.